Hi and welcome to our continuation of physics. Today we're going to be looking at calculating speed. So you're going to be able to use an equation to calculate an average speed. You're going to give the correct units in all cases that we look at. And we're going to look at something called the relative speed of objects that are passing one another. So as per usual, please make sure that your phone is off or in a different room. Don't have any other tabs on your computer to avoid it being slowed down. Answer all the questions, making sure that you pause the video or PowerPoint when you attempt them. You can always rewind and listen again if you are not sure about something. Do not give up. Please do the do now activity based on previous learning. Pause the video while you do the questions. And now for the answers. So if you've got forces acting on an object, if your object is stationary to begin with and the forces are balanced, then your object will continue to do what it was originally doing. So if it was stationary or still before, it will continue being stationary. If you've got forces acting on a stationary object that are unbalanced, so that means that you've got a larger force acting in one direction and not the other, then the object will accelerate in the direction of the larger force. Okay, acceleration is always in the direction of the resultant force. If you've got a moving object, and this time the objects are balanced, so again, if objects are balanced, if forces are balanced, the object will continue to do what it was already doing. So if your object was already moving and you put balanced forces on there, it will continue to move, but at that constant speed. It will either accelerate or decelerate. And if you've got forces acting on a moving object that are unbalanced, then your object will either accelerate or decelerate. It depends on the direction of the resultant force. On number 2, would you slide faster along the floor barefoot with socks on? Explain your answer. Well, obviously, you've all done this. It is with socks on. But again, why? It's because friction is reduced. So, when we come to look at speed is how fast something actually travels. And then the average speed is how fast an object moves over an entire journey. So if you think about going out in a car, you'll recognise that in a car, at a certain point, you're going at a faster speed, slower speed, and it might take you 10 minutes to get you from where you're wanting to go. The average speed would be the speed it took you to do that 10 minutes as an average value, just a single value, rather than all the ups and downs that you'd experience. Speed equals distance divided by time. So whenever you're looking for any type of particular speed value, you're going to take your distance and divide it by time. The standard units for speed are meters per second, and that's because distance is in meters, time is in seconds, and therefore speed will be in meters per second. We've done a lot of practice of this in terms of looking at the units that are in the question or the equation and using them to make the units of a final outcome. So if you ran 100 meters in 9.7 seconds, what is your average speed? Well, again, general exam practice, highlight the values that you need. Distance, 100 meters, and I know that's the hundreds of the distance because the units are meters. Time in seconds, 9.7. 100 divided by 9.7 equals 10.3 meters per second. That per is important because it's a divide. That per's got to be there. Make sure you've got m/s. On this example, the train travelled 303 kilometres in 2.2 hours. Calculate my average speed. Now, notice how on this one we've not got meters, we've got kilometres. And you'll know that 1 kilometre is 1,000 metres. We haven't got seconds, we've got hours. Now, this is an example of where normally in physics we'd always go for metres per second. And so if you'd have to convert. But actually in this particular example, so we can start getting used to the units, we can actually keep it in kilometres and hours. I don't want you to mess about with converting at this moment in time. Let's just focus on using the equation, speed equals distance divided by time. So I've highlighted my distance value, I've highlighted my time value, and I've placed them in the equation that I've written down so that I can clearly see what's being substituted where. So I've got 303 divided by 2.2, which equals 137.7 kilometres per hour. So it's not meters per second, we've not had to convert or anything. So in order to create the units of your speed, you can just use the units that you are given for your value of distance and time. And in this case, we were given kilometres and hours. So I can have a speed of kilometres per hour. You probably recognise now that a speed in a car is normally done in miles per hour. It's the same thing. You cover certain many distance in miles, and that takes you a certain amount of time in hours. So that's why you've got miles per hour as well. Cyclist travels at 3 meters per second this time. How long will it take them to travel 972 meters? So this time we need to rearrange the equation because we're trying to find a different value other than speed. So to work out time, once the equation has been rearranged, essentially you move the time aspect up to the top and bring speed down to the bottom, time equals distance divided by speed. You've already highlighted your values, so we know where to put them in the equation. So you've got 972 divided by 3, which equals 324 seconds. Again, make sure you're focusing on the units for the different ones. This is time, so the units need to be seconds. Car travels at 30 kilometers per hour. How far will the car have travelled after 1.5 hours? Right, so on this one, we're trying to work out distance now. So the equation is rearranging again. So distance actually equals speed times time. We've highlighted the values in the question. I've got a speed of kilometres per hour, that's 30 of them. I've got a time of 1.5 hours, so my final answer is going to be 30 times 1.5, which equals 45. How do you know what units are going to be for distance? Is it going to be meters, centimetres? What's it going to be? Well, look at the units in your speed aspect. It's kilometres per hour. Therefore, your unit of distance will be kilometres. Please attempt these following calculations on your own. Please use a calculator. Pause the video while you do them. Alright, now please mark your own. There are your answers. Please correct where necessary. So again, looking at the units, have you used correct units? You're not trying to convert anywhere. When you're using kilometres per hour, have you made sure that your speed is in kilometres per hour as well? And then you've obviously got the fastest speed reached by a human. If you didn't know, that was by a guy called Tom Jager. He set the record in a 50-metre race back in 1990 on the 24th of March. So nearly 20 years ago, or just over 20 years ago. Right, can you also now please pause the PowerPoint while you complete the speed calculations worksheet? Coming up are the answers, so please make sure you've armed yourself with your marking pen ready to correct. Okay, now for a scenario for us. So, when you're driving along the motorway, or maybe along a road, and often you might find that a car overtakes you. But when you watch that car overtaking you, it doesn't look as though they're travelling that fast. But actually, if you think of this, let's say you're on the motorway, you're doing 70 miles per hour. That's quite fast. If another car then overtakes you, doesn't look like they're going very fast. But if they're managing to overtake you, then they must be going faster than 70 miles per hour. So they're actually going really fast. Well, how can that be then? What are your thoughts on that? And the answer is relative motion. Okay, relative basically means compared to one another. And you may have heard the word relative when dealing with Einstein's, theory of relativity or special theory of relativity. Maybe not. So, if you remember when we first started looking at forces and how we treated them as vector values, they can be added together or taken away to give a resultant. Well, we can actually do the same thing with speeds, and that's what gives us something that's called relative motion. And it's always about the observed relative speeds. It's about what one observer in an object sees relative to the other. So when you're in a moving car, you see something different when you look at one object to, say, somebody who stood on the side of the road watching the same object. They would see it moving incredibly fast, where you see it moving incredibly slow. So, if objects travel in the same direction towards or away from each other, to calculate the relative speed, you subtract the lowest speed from the fastest speed. Alright, so that's if they're travelling in the same direction towards or away from each other. If objects are travelling in opposite directions towards or away from each other, you add the speeds. And again, this will give us our relative idea, so you're going to add the speeds. So for an example, two cars are travelling in the same direction on a road. So I've got blue car, yellow car. Try saying that over and again. Blue car, yellow car. The blue car is travelling at 25 meters per second. Yellow car travelling at 30 meters per second. What is their relative speed? Well, they're going in the same direction. So we're going to subtract them, right? Same direction is subtracting. So 30 take away 25 equals 5 meters per second. So one relative to the other looks like it's only travelling at 35 meters per second, even though we can clearly see that they're travelling at much higher speeds than that. So look at another example. A railway line and a road are side by side. A train and a car are travelling in the same direction, with the train in front of the car. The train travels at 52 meters per second and the car at 30 meters per second. What is their relative speed? They are in the same direction, therefore we subtract. Largest value, take away the smallest value. So 52 take away 30 is 22 meters per second. And you may have noticed this again when you may be in the car on the motorway and you see a train going past. That train's actually going much faster than what you perceive it to be because you're moving in the same direction. Right, on this example then, two cars are travelling on a road in opposite directions. The blue car is travelling at 25 meters per second and the yellow car is travelling at 30 meters per second. What is their relative speed? Now, this time they're in opposite directions. Because one's going to the left, the other one's going to the right. Therefore, we need to add the speeds. So 30 plus 25 is 55 meters per second. This becomes quite important when you think about collisions, and if you've got two cars coming head on, we can work out what their relative speed to each other is, which impacts on the collision. Please now have a go at completing the relative motion worksheet. Remember your rules: same direction, subtract; opposite direction, add. Please pause the lesson at this point to start that task. Okay, now that you've done that, please have a look at these questions. Pause the lesson again while you attempt these questions on your own. And the answers to those questions. So the correct equation for calculating speed equals distance divided by time. To be honest, you could have had distance equals speed times time as well, or time equals distance divided by speed. On this one, because the question says calculating speed, we'll make speed the subject. Speed of a car that travels 100 meters in 5 seconds, so 100 divided by 5 is 20 meters per second. Again, notice how it's meters per second. Which speed is faster, 10 or 1? Well, it's obviously 10 meters per second because you're covering 10 meters every second. And then subtract from number 4, add for number 5. So, if somebody was to ask how fast you walk or run then, what two measurements do you need to be able to calculate your speed? And how are you going to show your result is repeatable? Have a think about that for a couple of minutes while you pause the video. So what you need to do is you need to be able to measure time as it makes you cover a certain distance, because there's the two variables you need in order to calculate walking speed. In terms of the word repeatable is about doing the same thing again and getting a similar answer. So in your back garden, you might want to measure out your perimeter of your back garden, and you could walk around it, see how long it took you to walk around. You'd have a distance because you'd measure the perimeter, and then you could do the distance divided by the time, and that'll give you walking speed. And then you could record that, do that 3 times, measure an average, and that'll give you your mean walking speed. So there's an example of a table you could use if you want to have a go at of this in your garden. But again, you could change that 20 meters to whatever your garden perimeter is.